Welcome to Designfusion YouTube video channel. My name is Sanket Patel and I am an application specialist at Designfusion. This video is about how you can perform a motion simulation in NX. Right now you can see that I am in NX modeling environment where I have one basic engine assembly which has one piston connected to the connecting rod and it is connected to the camshaft. And camshaft is supported by simple base. So to perform a motion simulation you have to create or go to the motion environment where you can create a new motion simulation file. Once you create your simulation file, you can select the solver as you want. In our case it is NX motion. Let's select it and create our motion simulation file. Right now we are in motion environment where we have different command to create a mechanism by defining connector, contact and joint. So before that we have to define our motion body. So let's create our motion body first. So our first motion body will be the support. The second motion body is our camshaft and I am select the component of it and created it, and third will be the connecting rod, and last one is our piston. Once I created, now we can define our joint. Before that I will define my support as a fix, and let's create our first revolute joint between the camshaft and support. I have selected my camshaft. Then I need my center of origin of this circle, and then I need a rotation about z-axis, and my base would be this support. So I have selected it and created my first revolute joint. Second revolute joint between the connecting rod and camshaft. So I select connecting rod. I need my center of origin as a center of this pin, so I can create a center point between the center of two circles by between 2 points command. I selected and now I have my center point, and rotation is about z-axis. So I have defined that, and my second or base body will be the camshaft, and I need my center of origin as same as our connecting rod. So I will create it by between 2 points, and now I have my origin and my rotation will be about z-axis. So this way I define my second revolute joint and third revolute joint between the piston and connecting rod. So let's select the connecting rod, and I need my origin at the center of piston pin. So with using the same point command between 2 points I can create my origin, and once I created it I can define my axis of rotation, and it is a z direction. Same way my base body would be the piston, and I need my center of origin as a center of piston pin, and will use same command to create my center point, and the rotation would be about z-axis. So here you can define the friction as well, and you can define the driver definition in the joint as well, but we will define driver separately. So let's create our revolute joint. Once our revolute joint defined, we need to define a slider joint to our piston, because it is sliding into the cylinder and it slide up and down. So I defined it, and next we are going to define our driver. So we are going to define a driver at our joint 1. So let's select our joint 1 and where you have a different option to define your driver. So I will define as a function, and I need my velocity is vary from one value to another value. So I will define this in tabular form. My RPM is going to change from 800 to 2000 RPM, and I need my velocity in RPM, so I can select as I want, and I will define my data in table form. At 0 second my velocity is 800 RPM, and 10 second it is increased to 2000 RPM. So once I defined, I can also select that how my RPM will increase in linear manner or cubical manner. So I need it will increase in cubical manner, and you have a graphical representation of it, that how it is increased. Once I define my driver, you can also visualize. Here it is showing the rotating sign in anti-clockwise direction. Once I defined, my piston is under some compressive force because it requires some action to compress the air. So I can define the spring to replicate that particular condition, and I need my spring fixed point is 50 millimeter ahead from this center point of circle. So I will add that value 50 millimeter ahead from this center in positive y direction, and stiffness will be 8 Newton per meter, and force required to compress is 430 kilonewton. It is a compressive type of spring. So I have defined the compressive force by defining my spring, and last thing need to be remain is creating a solution. It will be the dynamic type of solution, and my end time will be 10 seconds, and I need total 1000 step, so I can get a value at that particular interval, and gravity will be in minus y direction. Once I define my simulation, we can right away solve it. It will take few seconds to solve. So now our simulation is solved, and we can right away check it and see the animation of it. You can also manage your speed factor as you want for better visualization. This way you can perform a motion simulation in NX. For more video, please like and subscribe our YouTube video channel. Thank you.